Hafa Adai students, for today we're going to look at performing operations between rational expressions. And as rational expressions are fractions, what we're going to do is actually just utilize some of the rules for multiplying, dividing, adding and subtracting fractions, but now with the added polynomials in each one. First off, to multiply rational expressions, we're going to look at how to multiply fractions, right? So if I was to have a over b multiplied by c over d. To multiply fractions, all you have to do is multiply across and then simplify. But for this case, it will just be a times c over b times d. Looking down here at letter A, so these are the steps that we're going to use to multiply rational expressions. And just keep in mind that you can actually, if you don't like cross canceling, you can actually just multiply across and then simplify from there. But I always suggest that you check at the very end one last time just to make sure we didn't miss anything. So looking at this letter A, I'm just going to write it bigger so that I have more space. I can see it a little bit better. 6d over 8c times 12c squared over 9d. From here, for me, I like to cancel things and then simplify. So what I'm going to do is actually just look at what can I simplify here. I know 6d and 9d, the d will be canceled, right? D is gone. Both 6 and 9 are divisible by 3, so I'm going to reduce this to 2 and this to 3 because I divided each of them by 3. This c is gone, the smaller c is gone. This is going to become c to the first power. 12 and 8, I know are both divisible by 4. This becomes 2, and this becomes 3. From there, I'll multiply across. I have 2, 3c, so 2 times 3c over 2 times 3. From there, I have 6c over 6. I can cancel again. We want to look one more time. Can I cancel anything? That's 6, so I'm left with just c. So when you're cross-canceling, what you want to do is find out what they're both divisible by and then divide each of them by that number to reduce it. And it has to always be one in the numerator, one in the denominator, either on the same or different sides. Usually we do it across. Looking at this example, again, I'm going to rewrite it so it's bigger. X over 2x minus 6 times 4x minus 12 over x squared. The first step in the other one was to factor, right? So I'm actually going to factor these two just to see what I might get, because there's probably going to be something that I could cancel out. 2x minus 6 divisible by 2. I'm left with x minus 3 times 4 times x minus 3 over x squared. So for this one, I can already see x minus 3 I can cancel. I might actually just work with this like this and then cancel later on. Here, 4 times x multiplying across, 4 times x is 4x. Multiplying across, we have 2x squared. And this is something that I can actually cancel easily. That's going to just become, this is going to be 2, this is going to be 1, right? X is gone, this becomes x to the first power, so I'm left with 2 over x to the first power. And just be careful because you might miss something that you thought you crossed out, but see there's still this x there, so I have to make sure that I keep everything that wasn't canceled out. So just be very careful with that. And if you were to cancel in this step more, the 4, 2, and then the x and the x squared, that would be good. Again, whichever way works for you. Dividing rational expressions. Dividing rational expressions is pretty much the same thing as multiplying, except we're multiplying now by the reciprocal of the second one. So, give an example. If we have a over b divided by c over d, we're looking at a regular fractional example. So this is going to equal to a over b multiplied by, I'm now changing to multiplication and flipping my second expression, the reciprocal of the second expression. So d over c. And then again, same thing, multiply across, a times d over b times c. So we're going to follow these steps for our division. Flip the second expression, factor if necessary, cross cancel, multiply cross, simplify if necessary. So we're just multiplying with that one added step in the beginning of flipping the second expression. So I'm going to flip this one. I'm just going to rewrite it flipped already. Okay, flip the second one. Next thing I want to do is factor each of them. So we have 7 t squared minus 36. I'll use the difference of squares. This is going to be t plus 6 times t minus 6. Multiplying this by, again for this one, I'm going to multiply the one that's on the bottom first, the easier one. 3t plus 18. I know I can factor 3 out of that. We have t plus 6. This top one factors at 36. That will give me a sum of 12 are t plus 6 and t plus 6. You could factor on the side if you prefer to actually check your work with your writing. If you can't do it in your head yet, then just do it on the side. So t plus 6, I'm going to cancel. There's one each. There's another t plus 6 here and one here. I might actually just write these all down. 7 times nothing. Okay, so 7 over. We're left with t minus 6 times 3. And I'm checking again, is there anything else I can cancel? Nothing else. It's our final answer. Flip, factor, multiply, cross. Flip, factor, cancel, multiply, cross, simplify. Moving on to this next one, we're going to do the same thing, flip it. I might actually just do in one step. Actually, no, I'll just rewrite it. X squared minus 9 times x squared minus 6x plus 9 over 9 minus 3x. Okay, we talked before about this 9 minus 3x, right? We talked about how when it's backwards, it's probably a trick question. So what I'm going to actually do is rewrite it so that it's negative 3x plus 9. It's in the way that I'm used to because I'm pretty sure I'm going to have to factor out negative 3 from here. Plus 9. Okay, from here I'll factor. Difference of squares, x plus 3, x minus 3, multiplied by x squared minus 6x plus 9. To factor this numerator, I'm going to think of factors of 9. That will give me a sum of negative 6, so it has to be negative, right? Both negative. X minus 3 times x minus 3. And then in this bottom one, I'm actually going to factor out negative 3, and I'll be left with x minus 3. See, it works out. Flip it. It'll be a lot easier to figure out what you need to pull out. When it cancel from here, I have an x minus 3 and x minus 3. Another one, I'm left with negative 8 divided by negative 3 times x plus 3. I don't want to leave negative over negative, so I'm just going to simplify that to be 8 over 3 times x plus 3. That's the answer. Easy stuff. Next, we're going to move into addition and subtraction. So basically, addition and subtraction, the same rules apply for these kinds of things. It doesn't matter if you're adding or subtracting. So we're going to do these all in the same examples. Okay, so we have a over c. We're talking now about like fractions. And when I say fractions are like fractions when they have the same denominator. So if you have a over c plus or minus, I say plus or minus because it works for both. B over c, same denominator. All you have to do is combine your numerator, depending if it's plus or minus, and then keep it over the same denominator. And so we're going to do the same thing if I have expressions. See, notice that my denominator of 2x is the same for both of these. All I'm going to do is just add my numerators. Keep the same denominator. This is going to be 8 over 2x. But again, we want to take that one last step to simplify where we can. Okay, so this is going to equal to, they're both divisible by 2, right? So we have 4 over x. For this one over here on the right, I'll use a different color, a different shade of blue. Okay, they're both divided by d minus 5. So what I'm going to do is put 15 minus 3d. I'm combining my numerator, keeping the denominator. You always want to factor again, right? So again, I have this 15 minus 3d. It's kind of weird. I'm going to flip it just because I usually like having the variable in the front, right? So we have negative 3d plus 15 over d minus 5. Here I can already see, okay, I can factor out negative 3 from this. I'm left with negative 3 times d minus 5 over d minus 5. And again, this worked out really nicely where I can cancel this and this to simplify to negative 3. So be careful. It might look like you're done, but you always want to check, is there anything I can factor out of this final thing? You always want to try to get it to its most simplest form. Especially in this lesson, there's going to be maybe some extra factoring at the end that you might not have seen before. So just always check your final answer again. Okay, so now we're looking into adding, subtracting unlike fractions. So again, if I have a over b plus or minus c over d, different denominators. What I should do actually, a good example, I want to have the same denominator. So I want a denominator that can divide both b and d. So I want to make it be the same. So I'm going to do that by multiplying this first expression here, a over b, multiplying that by both sides by d so that I can have a d in the denominator. So I want my denominator to be there, right? So anything I do to the bottom, I have to do to the top. Plus, I have c over d again. But I want to multiply this now by b to get a b there. And now, since I'm multiplying by the same thing on both sides, I'm essentially multiplying by 1. But it changes the way that my fractions look. So now they have the same denominator. BD is the same as DB, right? So the order doesn't matter as it's multiplication, but I need to have both B and D in my denominator. And since now I have the same denominator, what I can do is just combine this under one denominator, which is B times D, or D times B, and I'll just combine my numerator, AD plus or minus BC or CB. It might be a bit easier with examples. So here we're looking at letter A, 1 over 3 plus 3 over 5. My least common denominator of 3 and 5, the smallest number that can divide both of these numbers is 15, right? So I want to get it to 15. I'm going to multiply 3 by 5. And what was it missing? It was missing that 5, so I need to put a 5 in the numerator. Anything you do to the bottom, you have to do to the top. So we have multiplying this one by 3, top by 3. And now that I have the same denominator, I'm going to multiply these. So I have 5 over 15 plus 9 over 15. From here, I'll just combine and keep my denominator. So we have 5 plus 9 over 15. Oops. Which is 14 over 15. When we have variables, so there's two ways to do this. You can either multiply all these numbers together, or I might just find with their LCD. So I want my denominator to have at least a 4, a 9, and a 2 x's. So again, I want to see how I'm going to manipulate this first one and how I'm going to manipulate this second one. So the smallest thing that can divide both 4x and 9x squared is 36x squared. Because it's okay if you have an x here, as long as you have at least 2 x's in your final. So what I'm going to do is actually multiply this first one by 9x. Because I already have 1x, I just only need 2. So this one I'm going to multiply by 4. Do the same thing to the top. Just write a line between here. Here I have 9x over 36 x squared plus 16 over 36 x squared. So what I'm trying to do is get my denominators the same, right? Now I can just do this, 9x plus 16 over 36x squared. I'm going to do that last step. I want to see, can I factor anything? Look at this numerator. Are 9x and 16 divided by anything, divisible by anything in common? No. So actually, I'm done. But I do need to take that extra second just to think about my numerator or denominator and see if there's anything else I can pull out. Looking at this one, I'll rewrite it. Oops, that's minus. Okay, so now for my denominator, I want to multiply 6p and p minus 4. So my new denominator is going to be, so we have 6p, oops, this is a little bit smaller, 6p, then I have p minus 4, minus p plus 4 times 6p. So in order to get them to be the same denominator, I'm going to multiply this first one by 6p, both top and bottom. For this second one, I'm going to multiply by p minus 4. What is it missing? I'm missing that p minus 4, both sides. So for this one, I'm actually going to have to FOIL this section right here, because I can't leave it as 36p squared minus p plus 4 times p minus 4. I'm going to have to actually FOIL that and then see if there's anything I can take out once I add in that first one. So we'll see here. We have 36p squared. I know everything's going to be over 6p times p minus 4, right? So this minus p plus 4 times p minus 4, I know because the difference is squared, so it's going to be p squared minus 16. What I'm going to do from here, distribute this negative sign, which will give me, let me actually just write up here a little bit smaller, 36p squared minus p squared plus 16 over 6p times p minus 4. From there, I have 36 minus 1, 35p squared plus 16 over 6p times p minus 4. You don't have to multiply out this denominator because it's really only one thing, right? We have two different factors. The reason why I had to multiply this out is because I had to still combine it with this. So I'll multiply that, then combine. And from here, oh yeah, we're supposed to take one final step, see if there's anything in common. 35 and 16 have nothing in common, so you just leave it like this. Okay, now moving on to our last example. As always, I'll rewrite it. So we have 2 over x squared minus 7x minus 6, or plus 6, minus 5 over x squared minus 36. So once I see these polynomials, a lot of times when I'm looking at things like this, I'm automatically driven to factor it, right? Because I already know for when I'm working in this topic especially, I'm always factoring things. So whenever I see a polynomial, I'm going to try to factor it. So x squared minus 7x plus 6, I'm going to go straight into factoring this. So that's going to be x minus 6 times x minus 1. X squared minus 36 is using the difference of squares. I know it's going to be x plus 6 times x minus 6. Okay, so now I'm going to set up what I know my denominator is going to be, right? So I want to have at least one x minus 6, at least an x minus 1, and at least one x plus 6. Since this already has x minus 6, it's already covered from the other one. So my least common denominator is going to now be x minus 6, x minus 1, and then we have that x plus 6. And then I'm going to see, okay, what was it missing earlier from each of these? So this one did not have an x plus 6. This one on the right didn't have an x minus 1. So that's what I'm going to be multiplying my numerator by. So it started out with 2. So I'm actually going to multiply this by x plus 6. This one I started with 5. I'll multiply this by x minus 1. I'm going to multiply this out by distributing these 2 and 5 and then combining it. 2x plus 12. I'm actually distributing negative 5. So negative 5x plus 5 over x minus 6, x plus 1, x plus 6. Again, order doesn't matter for this denominator. Combining these, I'm left with negative 3x plus 18 over all of these. Oh, sorry, 17. Okay, negative 3x and 17. I cannot cancel anything or take anything out, so we'll just box it there. Okay, so I hope this lesson wasn't too confusing. I know this is actually a really hard one. So I'll try to find an alternate video just so you have more than one source when looking at adding and subtracting. I'm assuming that multiplication division will be actually very easy for you. So good luck. Please do the practice problems in your book just to practice. And I'll see you on Wednesday.